Hello, everyone. Welcome to another YugabyteDB demo, this time on the concept of replicas. My name is Marco Reichvich. I'm one of the solutions engineers here at Yugabyte, and I'll be taking you through today's demonstration. I've already gone ahead and created a 3-node cluster in EU. What I'm going to do now is I'm going to go ahead and, as a first step, create the replica cluster just to show you how to do that. And then we will go ahead and we'll query this primary cluster from the US, and then we'll query the replica and kind of show you the differences in latencies and the importance of having a replica for certain use cases and applications. So right now, what you're seeing for you is Yugabyte Platform. So I'm using Yugabyte Platform to be able to kind of play around within the demo today. I'll go ahead and click on Actions in the top right, click on Add Replica, click on AWS Portal 1. I'm going to choose a is this the right? Yes. So I do want to do this one. Go ahead and select a US region. You can see here that you can do a cluster of nodes, or you can do a single node if you want to. I'm going to go ahead and I'm going to do a single node right now. I just kind of keep things simple. But one of the things I will do in my primary cluster, I have 3 nodes, each with 2 cores, 4 gigabytes of RAM each. I'm going to go ahead and actually make that a little beefier. So I'll take it up to 8 cores. Everything else looks good. Let's go ahead and add our replica. Okay, so while that is being set up, I will go ahead and really quickly want to take you through what a replica is and why you would use it compared to some of the other some of the other options here. And within YugabyteDB, we've mentioned this in other demos, the default replication within your cluster is synchronous. And it's highly transactional, ACID compliant. However, if you have, you're going to have higher read and write latencies if you're globally distributed, right? If you're covering multiple regions, because we share data across these different regions, in order to get all of your data, sometimes it might take a little bit more time. So that's where the concept of geopartitioning, X-cluster, read replicas come in. Geopartitioning and X-cluster are both more for low latency reads and writes. Read replicas is when we want to unidirectionally with async replication, just have an extra node or extra couple nodes somewhere else in order to get the low latency that we want in a particular region. Right, so it's so what that looks like here today, and what we're going to be setting up is a 3-node cluster in Europe, and then we're actually going to have a single cluster here in the US. Ooh. But just know that if you wanted to, you could have more than one read replica node within that cluster. And again, it's going to be for real quick, seamless creation of a read replica for low latency reads in a new region. So maybe you're expanding user base, and you just want them to be able to read from a particular region. Have a note that read replicas can't be used for resilience and failover. They're only there as in order to serve reads, and they can't become they're not part of the primary raft election group when it comes to tablet leaders. So in order to go ahead and set up follower reads for the YSQL API, there's really 2 different pieces of variables that you need to know of. One of them is YB read from followers, which controls whether you're going to be able to read from a follower. And the reason by default this is false is because the fact that when you read from a follower, there's a chance that you get stale data. So this is only to be used in situations where your use case can have some level of staleness, but you can control what that staleness is. So for example, the default is 30 seconds, and you can set that maximum allowable staleness. If it needs to be less, you can go ahead and maneuver that way. If it needs to be more, you can do so that way. Right, so what are we going to have to do? We're going to have to go ahead and there's a couple of different ways to make it read-only transactions condition true. So we'll go ahead and run one of these, and then we'll kind of show you what it looks like when setting the follower reads on versus querying directly to the primary cluster. So what I've gone ahead and done is I've already created a table for us in here, and I just called it test. Again, just keeping it simple. And then let's see what happens when we go ahead and we locally from the EU run a select count star. See how long that takes. Oh, probably should turn on timing. So we can compare. There we go. So it's about 1200 milliseconds or 1.2 milliseconds. Okay, so now let's do a select star from test. And that takes about, if you look at the bottom here, it's about 3.6 seconds. Okay, so let's see if our, so our read replica is still pending, should be done here in a second. But now what we're going to do is once that is up, we're going to connect to it. We're going to go ahead and connect to that node. And then what we're going to do is we're going to show if we're going to the primary, querying the primary cluster directly from the US, how long that's going to take. Hint, it's going to take longer than 3.5 seconds. And then what we're going to do is essentially try to replicate this level of low latency in the with the read replica, right? So we are all set. We have our 3 nodes here. So if I take a look at nodes, we have our 3 nodes, the primary cluster in the EU, and we have a read replica in US East. So let's go ahead and connect here. Alrighty, so now let's actually use our YSQL shell in order to access the database. Dummy. Okay, awesome. So now we are, essentially what we're doing is we are going from, because we don't have follower reads turned on, right, by default, they are off. So just really quickly going back to the, here. So you'll see the default is false, right? So right now, this setting is set to false. If I query Yugabyte database from the US cluster, it's going to actually reach out all the way out to the primary cluster. So let's see what that looks like. Right, so select count star from test. While that's running, really quickly, just to kind of remind you, it took, where are we? Oh, probably would help if I turned on timing. Okay, let me run that again. Okay, so in the primary cluster, it took about 1.2 seconds. And then here, it's taking 1.3 seconds. Let me really quickly make sure that I have this turned to false. Okay. Well, it looks like it is still performing pretty well. Okay, I'm on the right node. All right, let's see how much a select star from test is. How long that looks. So if you recall here, it took about 3.6 seconds. And it looks like already it's taking us a little bit more. So as you can see, going cross region, especially when we're talking about millions of rows, there's a reason you might want low latency, right? Your application might not be constantly doing full table scans, but if they are, this is or if there's overall you want lower latency, this is why read replicas are so important, right? You're talking about 3.6 seconds versus what we're looking at the read replica, which is going to be 1.5 minutes, right? That's a huge difference. So let's go ahead and set YB read from followers to true. Okay, awesome. And then one of the other things that we need to do here, we'll actually just set the session as read only rather than doing it in a transaction. Okay, so we have both of those set. So now let's see, what it looks like. Let's see if we can get any type of select count star. Let's see if it goes even faster. Okay, so it looks that's about the same. Let's see the select star from test. Should be much faster than a minute and a half. There we go. So right there, it finished in 3.5 seconds, which pretty closely matches this. So we're talking about 3.5 seconds when using a read replica and turning on follower reads versus the minute and a half that it took to go from the US to the EU and scan the full table of 1 million records and return the results, right? So if I run this again, just to verify that we're going to get that lower latency, we do, right? So great, all right. Thank you very much for your time.